warehouse management and facility planning. So if we have, for example, 14 products and we want to place them on the screen in a way like we want to know where to place product A, is it next to the receiving or next to the shipping or right in the middle? So there is a way to know all this in details, and we're gonna go over it now. For example, like I'll show you the result, the one we obtain at the end, and I'm gonna explain to you how did we obtain this result, how did we move from this one to obtain this result to this one. To start with, warehousing is referring as a transportation at 0 miles per hour. Okay, at 0 miles per hour. And there are several types of warehousing. So we do transportation, consolidation, product mixing, docking, servicing, protection against contingency. If we need to talk about layout, so it is more preferable, it's not obligatory to use one-story warehouse facility, which means on the same level, move good in a straight line, use very efficient material handling, effective storage plan, minimize the space of the aisle as much as possible, and use maximum height of the building. The purpose for this, because you pay for the space, used or unused, okay, regardless you use it or not. So it's better to store up vertical, not just to store as horizontal. So this is extremely important. So you always have to store up as vertical. If we check those few layout, we always have the aisles and the storage of products. It has to be along the axis, the long axis of the warehouse. So in this way, this axis, which is the height, is longer than the width of the building. So all the storage, it must be along this axis. Okay, this one is a proper one because yes, it has an axis of all the arrows at all sides. The aisles are minimum, as well as there is an axis from the entrance here to the end of the storage, while here there's no axis, as each face of the storage island does not have access from an aisle. Okay, here they are horizontal, they must be along the long axis of the building, and here in proper layout because there is no access to the other departments. Okay, so let's start with the first example. We have 8 products from A to H, and we have the quantity per receipt and trips to receive and trips to ship. Okay, so I need to remind you the purpose is to place those products into the warehouse, which one next to the receiving, which one next to the shipping. Okay, so the purpose here is to do what? To find the average customer order size. Literally is to divide the quantity per receipt divided by the trips to ship. So 100 divided by 250 equals 0.4. The next step is to find the ratio, so trip to receive divided by trip to ship. The next one is to arrange them in a descending or ascending order. The purpose is if the ratio is less than 1, so you place them closer to the shipping. If it's greater than 1, we place them closer to the receiving. Okay, so it's greater than 1, which is G and F, H and A, they could be in the middle, but literally G, it has to be into the receiving, and B, E, B, C, D, they are closer to the shipping because less than 1, and A, F, H could be between the two. Okay, the distance is the same as we could see here. So we have G next to the receiving, B, E and E, B, C, D is next to the shipping, and F, A and H, the ratio is equal to 1, so we place them right in the middle. And we have to remind you, like the fast moving product, okay, we place them, if we have the same common entrance and exit, so we place them next to each other. If we have medium moving, it's right in the middle, and slow moving, we place it farther away from the entrance. So I did here a small Excel file. In this example, we have from A to E. Okay, so I need here to just to give you the So here, this is the main example. As we have department from A to N. We have the quantity per receipt. We have trips to receive and trips to ship. First, we start by calculating the average customer order size, which literally or quantity per receipt divided by trip to ship, and then we find the ratio, okay, which is trip to receive divided by trip to ship, 90 divided by 210, and we get all those values. So the next what I did here using Excel is to arrange those order, or is this ratio, a descending order and an ascending order, excuse me. Okay, so you got A to J. Okay, if I take you back to this one, I need to remind you, if the ratio is less than 1, we are closer to shipping. So the ratio less than 1, we are closer to shipping. So we start by, okay, so if it is, this one is A, M, D, literally, so we're going down towards this direction. Okay, A, M, D, C, and J. Okay, and then we start all the way down at the bottom. So we have E, we're moving up, K, N, F, and H, and the one in the middle remaining B, G, I, L. So we've got B, G, I, and this one is L. This is the one in the middle here. Okay, so this is the best way to do things. Like, we place them again. If the ratio is less than 1, we put them next to the shipping. If the ratio is greater than 1, we put it next to the receiving. Okay, we put it next to the receiving, and if it is equal to 1, we put it right in the middle. Now I need to sum up the steps. First, you know, if you want to calculate the average customer order size, you divide quantity receipt divided by trip to ship. But bearing in mind the following: we are here considering that all the units received per day will be shipped. If this is not the case, like we receive unit per day, we storing them and we shipping a quantity of this unit, so we need a new column which is quantity existing in the warehouse, and then how many units we're shipping out of this warehouse and how many trips. But here we're saying that all the quantity received will be shipped out, and this is like this is applicable as a case, but we have to take this into consideration. So I will repeat, like, all the units received will be shipped out. So we need to, otherwise we have to introduce a column, will be unit in the system, and then there's like this unit, kind of remaining unit in the system, and then how many are shipped out and how many are staying in the system.